So, modern physics, our first lesson is going to be the structure of atoms. So, I expect that by the end of the lesson, everyone should be able to define an atom, although I shall not emphasize this. Each one of us should be able to represent it diagrammatically. You must be able to define terms like atomic, or the proton number, atomic mass, or nuclear number, or the mass number. All of those are the same as well. Then you must be able to use nuclear notations to identify the atomic number and the mass number, and of course to calculate for each of them in addition to the number of neutrons. So those are what I expect each one to get by the end of this particular lesson. So let's begin. Atomic structure. What do you mean by a structure is simply like a representation, just like a diagram, something like a plan of how the atom looks like. Now, I know that when you're starting your chemistry in senior one, you defined what an atom is. What is an atom? Yes, respond. What is an atom? You can pause the video and think about it. Okay, yes, you'd say that an atom is the smallest indivisible particle which takes part in a chemical reaction. As far as we know at the moment, at this level, an atom is the smallest indivisible particle. Now, you cannot see it with your own eyes, which takes part in a chemical reaction. Now, as you progress with physics, you'll find out that inside the atom itself, there are other particles. And at this level, we'll be talking about the protons, the neutrons, and the electrons. When you go further, you'll split the proton into other parts, as you'll see when you reach there. So at the moment, you can take the atom, just like in chemistry, as the smallest indivisible particle which takes part in a chemical reaction. Now, an atom consists of basically three components, and that is the protons and the neutrons. All of these ones are found inside the nucleus of an atom. And that nucleus is surrounded by electrons, as we can see that here. So that is a 3D diagram, a 3D representation, a three-dimensional representation of how an atom looks like. But you can simply draw it like this, where you have the nucleus, and in the nucleus have the protons and the neutrons, and then around the nucleus we have the electrons. So that is what we need to know at the moment, that the inner part of the atom is what called the nucleus, and inside the nucleus we have the neutrons, we have the protons, and then we have the electrons which move around the nucleus in the shells, or what you call the orbits. So one thing that we need to note from the beginning, right from the beginning, is that always whenever we have an electrically neutral atom, by electrically neutral I mean that an atom which is not charged, whether negatively or positively. So in a neutral atom, always the number of protons is always equal to this number of electrons. Otherwise, in case an electron goes away, then we say that the atom is positively charged. In the case an atom acquires an electron, then we say that it is negatively charged. Later on, we shall see the charges of each of these. So we're saying that when an atom is electrically neutral, then there are the same number of electrons as those of the protons. So in case we say that an atom has 7 electrons, then automatically it means that it has 7 protons. And this is when it is electrically neutral. In other words, since as we shall see later on, the electron is negatively charged, since it is having negative 7 charges and then positive 7 charges, the protons are positive charge. When you add up these ones, they form a net charge of 0. So we say that they are electrically neutral. So that is about the neutral atom. Then, when you talk about the structure of the atom, there are some terms that we'll look at, and these terms are what we call the atomic number or the mass number. Now, an atomic number, sometimes we call it the proton number. We define this as the number of protons in the nucleus of an atom. Number of protons in the nucleus of an atom. That is how we define atomic number or the proton number. And we represent this using a letter Z, as we shall see later on. Then the mass number. What is the mass number? The mass number we normally represent it using the letter capital A, as we shall see later on. And we define this, the mass number or the nuclear number, all the atomic mass, they all mean the same thing. So we define the mass number as the total number of protons and neutrons inside the nucleus of an atom. So when I ask that, what is meant by the term atomic mass? Don't confuse it with atomic number. They're different. So atomic mass is the total number of protons and neutrons in the nucleus of an atom. Let's look at this diagram here. Assuming that you have that as an atom and is having 3 protons, remember they're found in the nucleus of the atom. It has 3 protons, it has 4 neutrons, and it has 3 electrons. I can ask a question that, what is the atomic number of this? What is the proton number of this atom here? The answer is simply 3 protons. What is the mass number of this? Can you guess? Okay, so it is 3 protons plus the 4 neutrons, you get 7 as the atomic mass. So this is a lithium atom and it's having atomic number of 3 and it is having the mass number of 7. So that is what we call atomic mass and atomic number. That's the difference between those two terms there. Then when we talk about the structure of the atom and having represented that using a diagram, and we know what a proton, we know where the protons and neutrons are found and the electrons are found, what are the differences between these 3 here? Think about this. You can pause the video and think about this. Try to answer these questions here. Okay, I hope that you've got that correct. So the proton is found inside the nucleus of the atom and its mass is taken to be equal to 1 and its charge is, have you got it correct? Have you thought about it? Its charge is a positive. Very good. Then the neutron is also found in the nucleus of the atom. Its mass is also 1. You can use 1 unit. And what is its charge? It is 0. It has no charge. Then finally we have the electron is found on the outside of the nucleus. In other words, it is found on the shells, or it is found on the orbits of the atom. And this one, you may not get it, you may just take it at the moment that its mass is 0.005 units. In other words, this is not part of our level here, but the mass of an electron is taken to be 1/18/20 of the mass of carbon-12. Don't cram this. I'm just telling what it is. So when you get 1/18/20, you get this one as the mass of an electron. Okay, what is its charge? It is a negative. Very good. That is very good. So that is very good. We are progressing together. Then in chemistry, in physics, we always represent an atom using the letters capital A, capital Z, and an X. I've talked about that in the previous part. So how do you represent an atom? How do you represent an atom? So we have this, that an isotope of carbon consists of 6 protons and 8 neutrons. I'll talk about an isotope shortly, what it is. So an isotope of carbon consists of 6 protons and 8 neutrons, and we're saying that this can be written as carbon-14, simply carbon-14. But what does this really mean? How do we represent this? So that 14 is simply the atomic mass, or what we call the mass number or the nuclear number. They all mean the same thing. And it is written up there. In other words, if we have the general notation of any atom as X, the atomic mass is written here and the atomic number is written there. So carbon 14 means that 14 is the atomic mass and 16 is the atomic number. Now, one thing that we need to remember here is that we've also talked about the number of neutrons. So in this question here, we can simply say that our A is 14, our Z, which is the atomic number, is equal to 6. But what is the number of neutrons? Can you guess? Think. So one time we say that the total number of neutrons and protons is equal to the atomic mass. In other words, we can simply come up with this equation that capital A is equal to Z plus the N. Please write this somewhere because we're going to be using it so often. So, for example, we can say that 14 is equal to 6 plus N, implying that 14 is the same as 6 minus 6 plus N. If I subtract 6 on both sides, this one cancels out and we'll get my N as equal to 8. So the number of neutrons for the carbon 14 is equal to 8. I'm going to give you a short exercise on this. Finally, the C is the chemical symbol, and it is what I use to represent it as the X. X is just the general letter that we use. The C is the symbol of carbon. Generally, this is what I mean. So, A is the atomic number or the nuclear, A is the atomic mass or the nuclear number or the atomic mass. Z is the proton number or the atomic number. And the X is the symbol of the element. Carbon, hydrogen, helium, lithium, and so on. So, an example is carbon 12. That is how it looks like. Inside the nucleus, we have 6 protons. And can you guess the number of neutrons? 6. That is very good. Hydrogen has 1 proton inside the nucleus. Can you guess its number of neutrons? 0. Very good. Just use the equation capital A is equal to Z plus N. Okay, let's look at the next element. Lithium. What is the atomic mass? 7. What is the atomic number? 3. Very good. And what is the number of neutrons? It is a 4. Very good. So you get 7 minus 3, you get a 4. Okay, so let's go to another part, the last one in this video, and that is anisotope. What is anisotope? I know that you've met this word so often in chemistry. What is anisotope? One thing that you need to note at the moment is that all atoms of an element, all of them, whether the atom is charged, whether it is charged or whether it is neutral, all atoms of an element have the same number of protons. All of them have the same number of protons. Don't confuse it with electrons, because you say that electrons can be lost, can be gained. So electrons don't move. That's why an atom can be positively charged or negatively charged, as so in electrostatics. So all atoms have the same number of protons. Now, if that is the case, if the number of neutrons change, then we talk about what we call isotopes. In other words, we define isotopes as atoms, normally there are 2 or more, as atoms of the same element with the same number of protons but different number of neutrons. I've highlighted this. Same number of protons but different number of neutrons. Those are what we call isotopes. For example, we have this one here. We have this hydrogen atom. Sorry, I have this hydrogen element. It is having 3 isotopes. The 1, the 2, the 3 simply represent the mass number, but they're all isotopes. You can see that in the nucleus here, we have 1 proton, no neutron. We have 1 proton, 1 neutron. That's why we have the atomic mass as 2. Those are what we call isotopes. More examples can have this. For example, I've talked about that hydrogen there. All those are isotopes of hydrogen. Hydrogen 1, hydrogen 2, hydrogen 3. Other examples, you can list these down, please. Write down the definition of an isotope and give examples. Another one can be helium. Helium-4, helium-3. What's the difference between these? Okay, yes, it is the number of neutrons. In this one, we have 2 neutrons, and in this one, we have 1 neutron. So if the number of neutrons are different, then we talk about isotopes. Another example is carbon. We have carbon-12, we have carbon-14. So carbon-12, as we shall see later on, carbon-12 is the stable one, but carbon-14 is unstable. Shall talk about this when you're looking at half-life. For example, in case you want to determine the age of the first man, for how long has he been dead? We call that one carbon dating. So we use carbon-14 as we shall see later on. And that is why it is very important. Carbon-14 emits a beta particle and decays to become a nitrogen. You shall see this later on. Don't mind about this. So I have an exercise here. Calculate the number of protons, electrons, and neutrons. You can pause the video and get the answers here. Remember, the equation is capital A is equal to N plus Z. And an element is X as Z. So you can pause the video and try out this question here. Okay, I hope that you've got the answers here. For example, I'm going to work out for the last one. For this one here, A is equal to 14, Z is equal to 6, and my N is equal to A minus the Z, which is 14 minus 6, which gives me 8. Very good. So a question can say that describe the structure of an atom X. When the question says that describe the structure, you simply state the number of protons, neutrons, and electrons. For example, I can say that describe the structure of carbon-13. I will simply say that carbon-13 has 6 protons, 6 electrons, and 7 neutrons. 7 neutrons. I hope that you haven't got lost where I've got the 7 from. Says here, you can just write down, you can pause the video and try it out. So the question says that an isotope of uranium, the chemical symbol is U, consists of 92 protons and 143 neutrons. Give the 2 different ways of noting this isotope. You can pause the video and try it out. Okay, I hope that you've tried it out. Our answer is that the mass number of uranium is given by the number of Z, the number of protons plus the number of neutrons, we get the atomic mass. So how do we represent this? We say that when representing, you use X, A, Z. So you can simply say that this is represented as uranium 235 or represented as this. And I would encourage you to use this notation here. So in case you got that answer right, then bravo, that was great. Number 2, the last one, determine the number of protons and neutrons in the isotopes noted below. Part A. You can pause the video and try this out. Okay, so part A, the answer is 7. Part B, 7, number of neutrons is equal to 6. Part B, protons are 27 and neutrons are 33. Part C, we've got 79 protons, 118 neutrons. And then part D, 94 protons, 145 neutrons. So with this, I come to the end of the lesson. I wish you the best as you try out the quiz in the next part.